Hey guys, today we're going to go over significant figures. We're going to explain what these are and give a few examples, and hopefully you'll be able to figure some of the questions out yourself. Okay, so significant figures, you may have come across this term as well as decimal places, decimal points. So these two measures of precision help specify the degree of precision in your answer. Obviously, like when you're measuring something, say for example the width of a table, there you can never be too precise. You can go down to the like 0.00000001 degree of precision, and even then you can get down even more precise. So generally in scientists or in the world of maths or physics even, when you're measuring something and you want to measure it to a certain degree of precision, because let's be honest, like after a certain point it doesn't really matter depending on what you're trying to measure. Significant figures and decimal points can help specify what type of or what degree of precision you want. Now, decimal points you might be familiar with. Decimal points, for example, 2 decimal points. So if we look at this number, you might like a number like 4,268, right? 0.432. If you need 2 decimal points in terms of precision, this answer would then become 4,268.43. Remember, because 2 is less than 5, so we round down. So in that case, 3 remains unchanged, right? Unchanged. Cool. We won't go into too much detail with decimal points, but significant figures are like decimal points. For example, if we look at, for example, the number 325.62, and suppose we want a degree of precision to 2 significant figures, right? So significant figures are different in that you start counting the significant figures from the first non-zero number. So first non-zero number, right? Let's put that there. Okay, so 325.6 would become 320, right? Because you 1, so that's your first one, that's your second, and then these will be just 0 for the placeholder, right? So 325.62 to 2 significant figures would equal 320. Right. Okay, what about 4,625.425 to 5 significant figures, right? So that would be 1, 2, 3, 4, 5. So you would then get 4,625.4. Okay. Suppose you get another. Okay, let's go for another one. 10,261.23 to 7 significant figures. So you got 1, 2, 3, 4, 5, 6, 7. So in this case, you write out the whole thing. 10,261.23. Okay. But let's get into a bit more tricky situations. For example, 123,456 to two significant figures. Right, so your first number would be here, right, number 1 and number 2. That's your first two places. So this would then become 1, 2, 3, 1, 2, sorry, and then the rest are just zeros. So 1, 2, 3, 420,000. What about this one? 426,794 to four significant figures. So 1, 2, 3, 4, and these two would become 0. So this would become 4,267 zeros. 426,700, that's what it would become. What about 0.12079 to four significant figures? Right, now notice how significant figures we're dealing with the first non-zero number. So this number here would not be your first significant figure, right? Because it's a 0. So the rule is, remember up here, the first non-zero number, that's when you start counting your significant figures. So it would be, let's get that out of the way, 1, 2, 3, 4. Okay, so this would become 0.1208, right? 1208, four significant figures. Let's go to the next one, 0.020789 to four significant figures, which becomes, so again, this one is not your first one, that's not your first one because it's a 0, and this would be your first number, significant value. So 1, 2, 3, 4. So this would then become 0.0207.9, right? Because we've got to round it up. This becomes 9. Now let's go further. 35.7051 to two significant figures. Right, so you've got 1 and 2. So this simply becomes 35. Okay, what about 0.21345? Yeah, to three significant figures. Okay, so again, 0 is the first non-zero number, so this wouldn't be it, right? There are 1, 2, 3, right? So this becomes 0.213. What about 0.01 to five significant figures? All right, now this might be a bit tricky, but it's the same logic or same principle applied. So it's the first non-zero number you count, 5 significant figures. So it wouldn't be this one, wouldn't be this one. So 1, and then because there's no other number, you've got to put the place values in there. So 2, 3, 4, 5, right? That would be 2, 3, 4, and 5. So this would become 0.010000. So just to reiterate, 0.01 becomes 0.010000, right? So there's 1, 2, 3, 4, 5 significant figures. Oops. That are needed. We'll do a couple more. We'll do 2 more examples, and then hopefully that should make it a bit clearer. So 0.003892 to 3 significant figures becomes, remember, so not this one, not this one, not this one, so that's 1, 2, 3, so it becomes 0.0038 and 9, but remember the 6 here rounds the 9 up, which rounds the 8 up, which then becomes 90. Alright, one last one, 699.501 to 1 significant figure, right? So that's your first significant figure, right? And then this, because this is a 9, which rounds that 6 up to a 7, becomes 700, right? Because you've got the point here, you've got to remember that this, you got to give the place values. But if that one was, for example, 689.501 to 1 significant figures, then this would become, use again 1, this would become 690, right? Yeah, so I hope that makes it a bit more clearer. Feel free to leave a comment down below if you need further explanation, or if you still don't get it. I hope that clarifies it a bit. But remember, significant figures again is a method of recording precision, right? To what degree of precision we want an answer. And you count it by the first non-zero number, whereas decimals, again, you count it after the decimal point. So if it's 2 decimal points, you count 1, 2. Significant figure is the first non-zero number. Thanks once again.